Hello, welcome. Let's continue the tutorial on mensuration 2. We are on the total surface area of a cone and a pyramid. Now, there are times that a sector of a circle will be cut out to produce a cone. When they cut out a sector, when you fold it, you can also form a cone. But in this cone is going to be a hollow cone, meaning there won't be any circle to be used to cover the base. So in this case, the total surface area is going to be basically the curved surface area. All right, and we know under the curved surface area, we know curved surface area of a cone is given by pi r what? L. Meaning, before I can be able to find, they are going to give me the sector. Then it will be cut out to form this. I need the radius. I may also need the height of the cone itself, which is not given here, but the slant height is given. Now, if I take out this very sector and fold it, the radius of the circle is going to mean the length here. So in this case, when I move, the radius will become the slant height. So it will be given in the question. But we cannot say that from here to here is also called a radius. But if you fold it, the line from there is going to be in the center of the cone. So that becomes the height of the cone. It's not given. Then the radius is also not given. But we can be able to find that. We know that this very, sector, we can find the length of the sector. If I have A, B, the length meaning how long it is, the perimeter around it. The length of this. How do we find length of a sector? We know the length of a sector is the angle subtended over 360 times 2 pi r. Why 2 pi r? Let me use capital R. 2 pi r because it is part of the circumference. And the circumference is what? 2 pi r. Alright. Now, if I fold this to form a cone, you can see that the circle here, the circular part here, is just going to be the circumference. You understand? This is going to be the circumference of this circle. Will be the same as the length of this arc. Do you agree with me? The circumference. What is here? This circle you are seeing here. You fold it back. It forms the length of the arc. It is the length of the arc. You fold it, it becomes hollow. So it becomes the circumference of the empty circle we are seeing here. So this simply means that this is the same as the circumference of the cone. So the circumference of the cone, it will be 2 pi r. This time around, the small r, the circumference here with the radius, it will be the same as theta over 360 times 2 pi r, which is the length of the sector. Are you with me? Good. Now you can see that if I divide by 2 pi r, it will cancel themselves. I'll be left with only r equals to theta over 360 times what? R. Where the r is going to be the radius of the sector or the radius of the circle that has been cut out. Good. The small r is the radius of the cone. The theta is the angle subtended by the sector. Definitely, radius, and arc produce a sector. There will be an angle subtended. So it means we can find that of the radius easily. We know the slant height. The height will just be part of a right angle triangle. So using a Pythagoras theorem, I can say that the length square equals to L square plus what? The A square plus R square. But we know this. We know this. This is what we can find. So A square will be equals to the L square minus what? R square. If you use this, you can find the height. The height can be found. The radius can be found. The moment the radius is found, the total surface area can also be found. And when we know this, we know this. We know the radius, we can find the total surface area, which is the curved surface area. I am using total because this is a hollow cone. I believe you get it. So we have a question like this. A sector of angle 60 degrees is removed from a thin circular sheet of radius 14 centimeter and folded to form a right circular cone. Calculate the curved surface area of the cone. We know the curved surface area is pi r what? L, where the L is the slant height, and this is going to mean the radius of the cone. Alright, from here we can see that your L is going to be the radius of the circle, the thin sheet, which is also the same as what? 14 centimeter. Now we need to know what the radius is, but we know the angle is what? 60 degrees. So we do substitution. So your radius will be 60 out of 360 times the radius, which is what? 14 centimeter. So what do we do? I believe this will go 1, 6. I believe 2 here, 3. 2 here, 7. 7 out of 3 centimeters. So the moment we know this, we are only going to do substitution. Our curved surface area equals to 22 out of 7 times radius, which will be 7 out of 3 times the slant height, which is going to mean, what do we get? 14 centimeter. I believe this will cancel this. Then 22 will multiply 14 divided by 3. So this will give us 308 divided by 3, and that will be 102.667 if we are leaving that into 3 decimal places. But let's include a unit. So 102.667 centimeters square to 3 decimal places. Don't forget the radius is having a centimeter. So if I put it there, then 14 centimeter. When the 2 centimeter multiply, it gives us the centimeter square. We can also calculate without the unit, and when we get to the final stage, we introduce the unit also. Alright, so you can see how we can find the curved surface area of a cone if it is folded from a sector. I believe the concept is clear and the idea is clear as well. If you like this video, don't forget to share it, comment, and come back. Let's continue. Bye-bye.